All right, so we're getting to the end of our learning objectives for this unit, and you may notice there's a brand new number. We haven't had a 4 here yet, and for the rest of this unit are these learning objectives focused on a brand new topic that we haven't covered before. But it uses a lot of trig stuff we've talked about, and also gives us a new way of thinking about an old thing. So since we're kind of combining multiple things that we've done before, that's why it's in kind of this section of the learning objectives, and it's called polar coordinates. This is kind of the key word for these last 4 learning objectives. They're all related to polar coordinates. All right, so let's say you were living in Mathland and you were at the point 0, 0, which is going to be right there. All right, how would you get to the point 2, 3? Which we know is right here. All right, now in the real world, if I had to walk from my desk to like a window or something like that, I would just walk in a straight line and I would just walk there. But in the math world that we've been living in up to Algebra 2, that's not how we would move from this point to this point. All right, we would move right 2, so I'd go right 2, and I'd go up 3. And that's how kind of we've been doing all this stuff on the XY plane. I kind of go left and right first, and then up and down. So I can go left 1, down 3, it will get me to that point. I can go left 3, up 2, get me to that point. Right 1, down 2 would get me to that point. But that's how we've always done things using these coordinates. All right, left and right first based on that first coordinate, up and down in the second coordinate. But when we're doing movement, we would prefer just to walk directly to each of these places, because walking in a straight line is going to be the kind of easiest thing to do. All right, so how can we do that in a mathematical way? The answer is going to be this thing called polar coordinates. All right, it's called polar because in our XY plane, we call this point the origin, but now it's going to be the pole, like the North Pole, kind of the top of a circle. And in polar coordinates, instead of having an x and a y, which x is left and right, y is up and down, we have an r and a theta. All right, so our r is kind of the distance we're traveling, and the theta is our direction on an angle. So if I have this point I want to get to, the first thing to do is what angle do I need to go at? All right, so this is the theta, and the distance I walk, this blue line, that's my r. So now this gives me the ability to kind of walk directly at a point. I just know what angle I want to be at, so maybe I want to go in a different direction. Maybe I want to go in this bigger angle, theta there, and I want to walk a really far way along that angle, and that's going to give me this point. All right, so it allows me to kind of start at the pole, that origin that we normally call it in our XY plane, and just go directly at the point from that pole. All right, so in this learning objective, we're just going to figure out how do we graph stuff in polar coordinates. So I want to graph the point 2, pi over 4. If this was an x and y pair, it'd be 2 to the right. Pi over 4 is a little less than 1. It'd be that point there. But we're not in our normal plane, which is called rectangular coordinates, and it's called a rectangle because you're basically moving in rectangular shapes. We're in polar. So in polar, we're still going to have our 4 quadrants. But even though it said is 2, pi over 4, I like to start with the second coordinate first. So pi over 4 is the angle I'm traveling along. And we know pi over 4, it's in our normal unit circle picture. That's when it's the 45-degree angle. So this is the pi over 4 angle. And it says I'm going to go along that angle 2 units. So maybe a unit is that long, and I'm going 2 units. So this is the point that I'm talking about. All right, so 2, pi over 4 is that red point. I'm going along the pi over 4 angle 2 units. All right, so go ahead and try to apply that to this. I graph the point 3, pi over 3. And here's the picture. I'm moving 3 units along the pi over 3 angle. So this green angle is pi over 3, which is the 60-degree angle. And so it's a little bit sharper than that last green line we had in the last example. I'm going 3 units along. Now 1 unit, 2 units, and 3 units is that red dot. All right, so if I erased all the notation stuff, just this red dot floating out there is that point in radians. Next, we're going to start dealing with negative signs. Because we need to have negatives when we're graphing stuff. So we want to graph the point -2, -2 pi over 3. Again, the first thing I'm going to do is think about my angle. All right, the angle, the negative sign means I'm rotating in the counterclockwise direction instead of the clockwise direction. 2 pi over 3. I've been doing radian stuff for a while, so hopefully you know 2 pi over 3 is normally in quadrant 2. But I'm rotating in the negative direction, so it's going to be this angle in quadrant 3. Right, so that's 2 pi over 3. But I'm going to go in the -2 direction. All right, so this, if I go along 2 pi over 3, those are all positive units. So I want to think about going backwards. So if I continue this line in the opposite direction, I'm going backwards 2 units and ending up there. And so I'm kind of pointing myself in the -2 pi over 3 direction. So that's this green area here. Then kind of walking backwards 2 steps. All right, so the negative here tells me about the rotation. The negative here tells me I'm going in the opposite direction of that actual green angle. All right, so try the same thing. Graph the point -1 pi over 6. And this is what you get. So pi over 6 is the 30-degree angle, so it's kind of shallow angle there. But I'm going in the -1 direction. So again, I kind of keep extending that angle in the opposite direction and just go 1 unit backwards, and it gives me that red dot in quadrant 3. All right, so your multiple choice question, which of these points is in quadrant 3? All right, so look at what each of these angles is going to look like. All right, remembering what the angles are and what the direction means. All right, which of these is in quadrant 3?